Many of you in this room today are educators in one way or another. And I think that even for those who aren't, probably everybody has heard about the Socratic idea of students sitting at the feet of the masters. Well, today, we have two masters, and we are going to have that chance. AGS counselor Josh Campbell is going to lead a discussion between Brian McClendon and John Hanke, both of whom are going to receive the O.M. Miller Medal immediately following this session. Brian and John, we're at your feet.
Well, first of all, thank you very much for joining us. I know you both have extremely busy schedules. This panel is going to be slightly different in the fact that this is intended to be a discussion. So we're going to talk through things, less slides, less maps. And as John mentioned, we will be awarding the cartography medal of AGS to these guys in the session following. And so you'll hear more about their background explicitly then, as well as you have their bios. But just as a brief introduction, Brian and John were part of the founding team at Keyhole, which ultimately became Google Earth. And then upon the acquisition, stayed at Google and ran the Geographic, the Geo team, which includes the products we all use routinely: Earth, Maps, Street View, SketchUp, if you remember that, Panoramio, the kind of the landscape photos, as well as the introduction of location into search results. Upon leaving Google, Brian went to Uber, worked on automated driving, the Maps team at Uber, as well as machine learning. And John, I guess, started Niantic inside of Google, built games that take the geographic space that we exist in and overlaid like a gaming tier over the top of that with Ingress. Is that the first one? Then spun Niantic out and released the phenomenon that is Pokemon Go, and as I just recently learned, a new game on Harry Potter. So I thought the first question that we want to be looking forward to what's going to happen in 2050, but I think there's a lot of value in kind of getting your perspectives on when you were thinking about Earth Viewer, original Google Earth, and thinking about scales of data and scales of users that most people were not really conceptualizing. I'm just thinking, can we explore a little bit about the past and how your tech stack evolved, and what lessons did you learn in that could be used to be a framework for us to project out forward? Because it's been, 17, 18 years ago that Earth Viewer was started. So with that, I just kick it off to you guys.
Yeah, it's interesting to think back to that time. I know Brian and I had many debates in the office, along with Michael Jones and some of the other founders, about the trajectory that technology was going to follow. And I mean, that adage that you cannot intuit exponential change just could not be truer. And even today, I struggle with that. But in terms of storage, we talked about how much storage would we need to store an imagery model of the entire Earth. And we talked about a Kmart full of disk drives was the analogy. We have to fill it up with racks. And, to get to that level of storage, we never built the Kmart of disk drives because storage, the capacity increased so fast. We ultimately probably did have that volume of drives, but it stored vastly more data than we anticipated at the time. We had debates about, would this thing ever run on a mobile device? We had visions of building this digital Earth, and maybe there would be some futuristic version of a cell phone that could run it. And there was a lot of debate about if and when that could ever happen. And Brian was a little pessimistic, as I recall, but we got there. So those are some of my early recollections.
So it's rare that I get accused of being pessimistic with respect to technology, but I think that the Bill Gates quote about the people are optimistic in 2 years and unable to predict in 10 years is very valid, and we saw that certainly with Keyhole and Google Earth. The challenges around 3D graphics, even when we were launching it in '99, we were doing these demos on these very big PCs. I mean, $4,000, $5,000. It was really hard to haul them around to the venture capitalists to get money raised for it. But we had to convince them that this was coming and there would be a lot of these users and this would be eventually a consumer product. And it was really just a matter of when. And with respect to mobile phones, yes, there was some debate about how soon that 3D graphics would really be viable on mobile phones. And turns out it was still several years away, but it did happen. And certainly the iPhone and then Android after that.
8 years.
8 years from the prediction.
Discussion,
Yep. And so I think those are both things where looking at the future and trying to predict where it's going to be, you have to figure out how to make decisions that predict that. And if you do it wrong, your small company may fail, but you may be right in the long term. And I think one of the challenges is that small companies and startups can't afford to be that wrong. They're really gambling on this hit, and Keyhole just barely scraped by through some hard times, but we did make that prediction.
Yeah, it was, I mean, we were banking on 3 kind of simultaneous changes happening in technology. One was consumerization of 3D graphics, which had been the domain of high-end workstations that was coming to consumers through early work at NVIDIA, ATI. The broadband internet, so actually when we started in 99, 2000, a lot of people were still on dial-up, so broadband was not yet a thing, so we had to anticipate that it really was going to happen, that people really were going to have broadband at home. And then the third was digital imaging and the commercialization of essentially government overhead surveillance technology, that being privatized, and then that digital technology spreading to aircraft and other collection vehicles. So we were really at the point where all 3 of those things were kind of about to happen, but hadn't quite gotten there, and we were banking on all of them happening at the same time. And as it turns out, all did come to fruition there in a very short period of time.
So after you're acquired and you come into Google, and now all of a sudden the portfolio of potential geographic tools starts to expand, how are you thinking about the interrelationships between what Earth could be versus what maps could be? Where did Street View, where was that concept born? How did you see all those relating together?
So the entry into Google was very interesting. I mean, John and I actually had a big debate about getting bought by Google, because getting acquired by a big company, we weren't sure what they were going to do with us. And here, John was the pessimist and I was the optimist, as I remember. Realized that the things that we were missing as a small company in actually the 3 categories John mentioned were bandwidth, storage, and imagery. And Google, with its money and its infrastructure and its network, actually solved all 3 of those pretty much very quickly. And I think that the expansion of the imagery we were able to do by getting a lot of satellite imagery along with aerial imagery, the bandwidth that Google was able to provide us, because they already had this installed infrastructure for search, we then kind of abused it, because when we launched Google Earth, we used more than half the bandwidth of all of Google in those first 6 days and scared the company quite a bit. And we did a lot of changes very quickly to figure out how to get more copies of the data spread out to the edges and be more efficient on the network, and we were then able to unleash it on everybody. But the storage also, the storage technologies that Google had were far in advance of anything anywhere else in the world, and we were able to make copies of all that imagery in many, many places and produce a better experience. How to integrate with Maps and Street View, I think Maps benefit from many of the same technology things I just mentioned. Pre-rendering of map tiles is why Google Maps is fast. Integrating of the satellite imagery that we had in Google Earth into Google Maps is one of the big things that launched Google Maps on its huge adoption curve. And Street View is its whole other thing. I'll talk about that next.
Yeah, I mean, coming into Google was a really interesting experience. We were acquired by Google just before Google went public. They were this mysterious company a few blocks away from our offices. They were nearby, but we knew almost nothing about them, other than that they were rumored to have lavish spreads of food every day at lunch, and their employees were rumored to get massages, which I thought was just way over the top. Like, this company couldn't possibly be successful if it was spending so lavishly on perks. They showed us their financials while they were making the offer to acquire us, and I changed my mind about that. But the thing for us is we thought at Keyhole that we had come upon this vision for mapping that wasn't shared by the Yahoos and Microsofts of the world at that time, and that was this idea of an Earth browser that you would build up this base map of the entire world, and then through that you could discover many other kinds of information and lay things on top of it, and it would all be very friendly like a web browser. And at the time, the search engines, as we knew them, they looked at mapping as a place where you got directions and printed them out to take with you in your car. So it was really a MapQuest kind of product, and it was all about just really getting driving directions. And we weren't sure if Google wanted to turn us into a team that made, a MapQuest competitor, or if they really were bought into this vision that we had of assembling all the world's geographic information. But it was the meeting with Larry and Sergey and Eric when we kind of put the question to them, well, what's your vision for us if you acquire us? And I think it was Larry who spoke up and said, well, it's our mission to organize the world's information and make it universally accessible and useful. And we see geography and geographic organization as being a key part of that mission. We think there's a ton of information in the world that makes sense to be organized not through a search index, but according to spatial relationships. And so, it was clear that they had this much bigger vision for the company, which they followed through on with all the funding that we asked for and permission to go out and acquire massive amounts of imagery and street view cars and everything else. So, interesting ride.
Well, it made me think of one other element. I mean, so much of geospatial tech that we're all using now was pioneered at Google, whether we really understood that or not, whether it was Slippy maps and pre-rendering of map tiles, this idea of the 3D globe, which is now, hardware's gotten fast enough, browsers gotten fast enough that can actually live in a browser now. The vector tiles, which was one of the first things that was done by Google Maps, and now Mapbox does a lot of work with. Makes me think about keyhole markup language in KML and kind of what was the thought process between we need a different format versus what was an available range of formats at the time?
Well, I think I'll talk to that one. So I think the challenge was that, from the very beginnings of Keyhole, we wanted to be able to have the ability to share locations on the map. And it was kind of a very simple early task, was just creating place marks. But we immediately realized that a lot of people want to put much more data on the map. And so we looked at the existing formats, and I think people are familiar with shapefiles, which were extremely ubiquitous, but they suffered from the problem that you had to load like 4 files in to display anything because they had separated out everything into components. So it was unwieldy from a consumer perspective, and it wasn't expressive in 3 dimensions, or actually in time or in animation or several of the other issues as well. And so we built KML to solve that problem of single file, dynamic, 3D, and being able to tell stories on top of a map in a somewhat self-contained fashion. And so, KML allowed Keyhole and then Google Earth to be able to let other people tell their stories on top of the map, which at the end of the day is really what maps are about. The base map is mildly interesting. All of the really interesting stories come from the data on top of it.
It was interesting in the BNSF presentation this morning, you had a train company who's flying drones to inspect their rail lines and assets using high-resolution cameras and photogrammetry, storing massive amounts of pixels, and the user interface was still Google Earth. And they were raving about the simplicity of just allowing people to visualize and move quickly, which essentially is kind of the art and craft of cartography, right? So that pivot into this digital world, even 20 years later, is still being used.
I would add on to that, we had this vision, and we got it partly right, but one of the things I don't think, and correct me if I'm wrong, Brian, that we really anticipated that ended up being one of the most powerful things that happened was this sort of integration of maps into what you could think of as like part of the operating system of the internet. And that was really kind of an accidental thing. And I think you would have to give Brett Taylor, Jim Norris, Lars and Jens Rasmussen, who were on the Maps team, which was all ultimately ended up being part of the Geo team. But it was this idea of mashup. So Google Maps got launched, and people immediately started wrapping the HTML of the map into their own websites. Paul Rademacher did housing maps famously, which took Craigslist for rent listings and put them on top of a Google map, went viral, Wall Street Journal wrote it up, and then everybody started doing it. That led to a formalized Google Maps API, and then at that point, we had our idea of this sort of browser of all the data, but then there was the map going out to the data and to all of the sites and services across the internet, and that was really pretty fundamental to have this free global mapping service with an imagery layer that anybody could take and build into their own website with just really a few lines of HTML to pull that in and then start adding data on top of it. and it opened up so much. So that API interoperability being part of an ecosystem, that's an incredibly powerful concept that we only kind of stumbled into, I think, and is, maybe the biggest legacy there.
Yeah, the birth of neo-geography, that name's kind of fallen out of favor, but that was a huge debate in the geo community for a long time, the paleo nerds versus the neo-geographers.
The 20 million websites that adopted Google Maps API sort of made it pervasive throughout the web, and now we have iOS and Android also with Maps API available for their apps, and you're seeing many, many applications built on top of this sort of ubiquitous globe or ubiquitous map, and it solves many of the hard problems that then allow them to tell their stories on top of it.
Yeah, and then you took KML and took it to OGC and released it as an open format, kind of inverting the typical standards process with something that had a major footprint already in its utility, and it just continued to be adopted from there. Well, as we roll forward into this idea of like, okay, now can we, what does the future of geospatial technology look like, particularly as it relates to mobility? I'm struck by the things that you said were issues in '99. The consumerization of graphics cards, bandwidth, availability of pixels, and storage. That story really hasn't changed much, but it's right. But it's how you would think about those four things is now fundamentally different. It was kind of stunning to think like, well, what is GPUs now, 5G, microsats and the raining of pixels and point clouds that are going to come down from the sky. How has that changed the game? Where are we now as you level set?
So I would say, the future is really about autonomous vehicles and the collection of even more data. So Street View, on the order of 20 petabytes of data over 40 million miles collected. That's a single picture every 3 meters. But autonomous vehicles are out there collecting data every second, sometimes 10 frames a second for LiDAR and for the imagery. Many of them have several cameras on the car as well. The data streams are in on the order of a terabyte an hour. And that is the data that is being collected both to test the car, but also to create the maps that are necessary for this new kind of use case. The very high resolution maps that are needed for autonomous vehicles will make sort of all the work we've done on mapping to date look easy by comparison. And it will also have to be maintained at a much higher level of quality with low latency fixes and everything else. And they're all bottlenecked by exactly the same things. Storage, except now it's in the terabyte an hour kind of range, and in GPUs, and this is machine learning sitting in the car, being able to infer information about what the cameras see so that they can make determinations about where to go, and then bandwidth to be able to either uplink what's being seen or to take commands down to the car. 5G is coming, but even today you cannot get a reliable cell signal consistently across a city, even in New York, but certainly not in cities around the country and around the world. So it's the same problem, just add 2 zeros to everything we had before.
Yeah, it does seem like a pretty obvious continuum. We went from abstracted vector maps to realistic imagery-based maps to three-dimensional imagery-based maps to street-level 3D imagery-based maps, now to very detailed ground-level semantically intelligent maps where not only do you know what things are, you know what they are and what they do, and rules for navigation and other things that are semantically important to understand. And that there seems to be an insatiable appetite by computers and applications to know more and more granularity of that data. So since those applications are eager to sop that up and make use of it, it feels like there's going to continue to be a demand to keep mapping it at ever greater levels of granularity with ever greater frequencies of time. And I think the key thing that also came out of left field, and I certainly didn't predict, was the machine learning and the semantic understanding of the world from that mass collected data. That's pretty transformative, that you can go and drive a camera around, which is just a dumb pixel collector, but machines on the other side of that can turn those dumb pixels into knowledge about objects and know what those objects are and what they can do. Then you've got something that's really fundamentally different. And when you think about then what machines can do with that and how they can process and analyze that and use that to improve so many other processes and functions that need to be done, that's pretty mind-blowing. So that demand for that data, I think, is very, very high. And you see that in the self-driving car industry for those of you not following sort of the Silicon Valley venture capital world, is just exploding. You know, experts in computer vision, machine learning for application to self-driving is incredibly hot. People are getting paid incredible amounts of money to go and pursue that. The other side of it, where I guess Brian and I kind of went different directions. Brian went cars and Uber, and I went people with Niantic and our AR games. That human scale mapping of the pedestrian world, the walked world, all of the places that vehicles don't go, but we all go. That can also benefit hugely from that same kind of mapping, that same very detailed point cloud mapping with semantic understanding of them, what's behind it, and then that is what powers augmented reality. The vision that many of us have of glasses that you wear that has information about the world and allows you to interact with things in a very seamless and natural way. That to exist, you have to have that mapping data, and you have to have it everywhere. Places that are not accessible to cars and vehicles. And that's a problem that we're excited about trying to help solve at Niantic.
Yeah, I mean, you mentioned the idea of glasses. Are there particular hardware bottlenecks around, or what is holding back the idea of having the glasses, or are we there?
That was our dinner debate last night.
That's right.
Go ahead.
Well, I mean, John's actually probably seen more of the great demos than I have, but the challenge, if you take, let's say, Google Glass as version 0.1, and if you take Microsoft HoloLens as version 0.2 or 0.3, a 1.0 is still, in my opinion, a few years in the future. The challenge is really around the battery life in a pair of glasses without hurting your nose as it's sitting on it. Literally, and then there's the display technology to put things in front of your eyes that convince you that it's there, and do so in bright sunlit areas, which is another challenge because that takes more power. And then finally, to be able to know exactly where you're looking so that when you put these objects in your glasses, they line up with the world around you. So the ability for the glasses themselves to locate themselves in 3 space and in the map that they're holding in the world that they downloaded from the cloud probably, and being able to correctly draw the objects intersected with the world around you. Those are all big challenges, and I would say that it feels to me like we're still a few years away from an expensive but a good device, and then I think I told John yesterday, and my prediction was that we're a decade away from cheap consumer, everybody has them or everybody could have them glasses that allow for a really great augmented world experience, because the challenges, again, in several different areas have to line up, but everybody's working on this, and I'll gamble they'll fix it.
Yeah, I mean, the part that's going really well is the Moore's Law part. Collecting the pixels, understanding the pixels, and then rendering new pixels to change your environment, provide information to you, put a Pokemon in front of you. Like, all that's going exceedingly well because chips continue to get smaller and faster and smarter, and the software gets better and better, so we can do more and more. The two hard things, I think, are really, it's us as humans, we're the problem. Because the interface into the human brain through the eye is unfortunately bounded by things that aren't really affected by Moore's Law. It's really about physics and the biological interface of getting some signal, say photons, into your eye to create this illusion of things being overlaid into the real world. And the constraints there are really around optics and physics and things that don't move at the same pace as electronics and software. So people are trying very, very hard to create solutions to get the photons into your eye in compact ways. But I don't know. You can maybe see that problem getting solved, but it hasn't. It's not solved yet. So really getting that information, into the human brain ultimately is the tough part.
So I'm interested in this idea of the feedback loop between the base map and then these respective technologies operating on the base map, but also contributing back to the base map. I think with the cars, one question would be, okay, you're collecting a terabyte an hour. Certainly, if you've got 1,000 cars going down the same street, not all that data needs to come home. Like, what percentage do you think data do we need to be pushing? Do we need to compute at the edge in the car, and how much do we need to push back?
So I mean, I think that's a good point long term. Right now, the challenge is that you want as much test data as possible, but that's in the prototype form where you have 10 cars, 50 cars, 100 cars. When you have 1,000 cars or 10,000 cars, yes, you cannot possibly reconsume all that information, and so you have to decide what you want to pick. And so I think part of it, the cars will focus on two aspects. They'll want to detect change in the world, in the data that they're collecting. Like, I have this map and I'm collecting this data. Oh, look, it's slightly different. I'll just remember that portion, the portion that's changed. And the other part that they'll want to collect is, I just had a near miss where I had to swerve. Let me record that information to see if I can improve the driving quality of the next set of software that comes out, because this was a risky situation. And in the case of today with self-driving, when the safety driver takes over because the computer made a mistake, every one of those is a must-save opportunity, because that's a case where we know the software failed and we need to make sure that all software in the future does not fail in that particular case. So getting all of the failure cases collected is a sort of one of the focuses, and it helps narrow it to a degree, but mapping and consistent worldview will cause us to always want to upload data.
So from the pedestrian sense, right, you've got people traversing in totally different ways. I would think that I would think the enrichment opportunity coming back from the telemetries while people are playing the game would be, I would think there'd be a lot of opportunity there.
Yeah, well, there are trade-offs. I think, computer scientists would want as many of the pixels to be back on the server as was possible, because your algorithms are always going to get better and you're always going to be able to do more to process that and get useful things out of it. But that means you have to transmit a bunch of data over the wire, and that, consumer may not want to do that. So I think there is a huge advantage to computing at the edge and extracting just those nuggets of data that you need from pixels and just transmitting those nuggets back. There are trade-offs there too, though. It just takes CPU usage, takes power on the phone, and you have to decide when to do that, when it's appropriate to do that. So.
But I think that one of the challenges, another reason to do it, though, is going to become very apparent. And I think the first Google Glass challenge, the reason I think it got a lot of heat was that it was this camera that walked around with you, and it was a privacy issue. And so if you do your processing on the device and you only upload some transformed data back to the cloud, then this is no longer personal pictures of the world around you. It's geometry about the change in the world. I think that greatly decreases the risk of privacy leak to the cloud, and I think that's going to become a requirement, certainly for glasses. For cars, I think it's going to be an issue also, but there's still kind of a general belief that if you're on the road, cameras taken in public can be collected. But I think if we collect all the video there, we're going to have to figure out ways to chop it into pieces, not collect it all. Otherwise, we are in a surveillance society before we know it, and that's not a good situation.
Yeah. Well, I definitely want to open it up to folks in the audience. Are there any questions? Yeah, if you can, please use the microphone.
Hey, George Percival. First time I saw Google Earth Keyhole was at a Digital Earth meeting by Good Child at Santa Barbara. Mm-hmm. Gore lost. We didn't do that, but you guys have succeeded well. I went on to be now with the Open Geospatial Consortium. And so first, I'm a fanboy. You guys have done tremendous work, right? Really appreciate what you've done, and thank you for that. So two questions, really, maybe one to... The near-term question and the long-term question. The near-term question is Google Earth is now open source. What happens with that?
So I would, it's, as far as I know, Google Earth itself is not open source. Google Earth Enterprise, the GEE, is open source, which means you can create globes and publish them to the Google Earth app, but the application itself is not open source yet. KML is, of course, an open standard.
Open standard, absolutely. The other question is, with respect to the machine learning question, and some of the things we've considered in this conference over the last couple of days is kind of more the social implications of the geography and the way in which we assess and determine our geography. What we know with the deep learning algorithms is we don't know why they're making the decisions they are making. We look at these nodes, 30,000 nodes and 200 million connections or whatever, and we get an answer, and we like the answer, but there'll become a time at which we can't understand that answer. So do you have any thoughts with respect to the future technology of deep learning for creating geography facts?
I mean, I would treat, deep learning and machine learning as effectively a tool. When it's right, and it's useful, and go ahead and use it. But if it's producing surprisingly wrong results, then you need to figure out a different, retrain the system with better data that doesn't have that problem. Because
Practical.
it is true that the stack of neural network programming does not lend itself to debugging at all, but the data that you put into it, your training data, is yours, right? The more you have of it, the broader in spectrum it is, and the more accurately it's labeled, the better the system's going to be at producing those results. Absolutely. And I think that's how you think about it, is if you're seeing problems, get more data and train a better system.
I don't think it's a reason not to use those systems, though. I mean, they're so powerful. I read recently about some work that was done where they looked at Street View data to determine walkability, like how friendly is this neighborhood to pedestrian traffic? How welcoming is it? And they were able to assign a score, based on a train system with Street View data as the input. And it's just super useful. I mean, how else would you be able to get to that kind of data set at scale? And then what can you do with that? So many interesting applications.
Absolutely. Cool, thanks.
Yeah, Bob.
Bob Chen here at Columbia University. I just wanted to pick up on one of your last comments about, for example, the privacy issues associated with the data. But the flip side is that same data is going to be needed for legal purposes. It's evidence of an accident. It'll be used in court and so forth. And that's part of the larger issue of who controls that data, who owns it. Have you guys started thinking about that? Do you have positions on those access, ownership,
I mean, I think
control
that
issues?
for the purposes of a car crash, which involves an autonomous vehicle, then that data is going to be part of the evidence that's provided, and the courts will require that it be delivered, and the companies who built the vehicle will want it to be delivered because it will be pretty tangible evidence of that specific thing. What I'm worried about is when it's not part of any existing crime, and it's just a collection of video, and somebody wants to subpoena it. In my opinion, we shouldn't be storing that data long term, because we don't really want a history of every little minor infraction that everybody's ever done in their lives. But in the short term, I think that is being collected, but right now it's not coverage-wise material.
I mean, there's the issue of ownership. There's also some issues around collectability of the data, like what areas can be mapped, or could somebody say that an area can't be mapped? I would think most people in this room maybe would generally agree that public spaces, those spaces that are available and open to the public, ought to be free to be mapped. We perceive them, we map them ourselves as we interact with these spaces. So why shouldn't machines be able to help us do that and unlock new capability? However, that's something that I think probably is going to be debated to some extent in this area. And then you get into sort of semi-public spaces like this room, for example, and whether the University of Columbia would allow it to be mapped, or would they exert some control over that? It could get very cumbersome and complicated if people assert those kinds of rights, and I'm not sure how it would shake out legally. But for the data to be collected, for the applications to be created that would be most useful to the most number of people, obviously, a more open attitude towards that would yield better results. But I think it is something that we'll see debated over the next few years.
I'm fascinated by the idea that in your success, serendipity has played a significant role. That there is the aha moments. And my experience has been the aha moments don't announce themselves. You've got to discover them on your own. Therefore, there must be something in your background that allows you to recognize those. And I'm interested in what you think that is and whether or not we as educators can teach that.
Yeah, that's an interesting question. I mean, I think my aha moment for Google Earth as a product actually did announce itself very specifically that's one point where I saw it working on a PC for the first time. We had seen it working historically on very expensive machines, but once you see it working on the same computer that you use every day, suddenly my mind shifted and I believed that this could be accessible to a lot more people. In general, being exposed to a lot of different technologies, reading about, in the case of computer graphics, right? I didn't just study geography. A lot of the 3D graphics testing and applications that were built on top of things that I worked on were geographic information systems of some sort or flight simulation. But I actually got exposed to a large amount of what the world is doing with 3D graphics during my time at Silicon Graphics, which preceded all of this. And so I saw a broad stroke of the entire pixel industry, as it were, and I think that helped me to see what was possible. But reading about technology, reading about all of the different problems that are trying to be solved, usually you'll discover there's a cross-pollination between them.
I don't know. One thing that comes to mind I struggle with as a parent, but I think it may be a good idea to allow kids to be bored. I grew up in a very small town of 1,000 people in a rural area, and there was almost zero of what we would think of as enrichment opportunities that we shower our kids with today. But there's something to be said for having that downtime and letting your imagination work. There's probably some good that we can do our kids by giving them that opportunity.
Awesome. Well, join me in thanking the
Great.
gentlemen
Thank
for the
you
time.
very much.